Hi everyone, today we're going to be doing section 1.4 in our algebra book, and basically we're going to be working with properties, and there are 7 properties, so there's going to be a lot of notes in the beginning here. So write down the blue at the top for your title, then write down the 7 properties. The first property is the commutative property of addition. And you're going to write that whole thing down. You're not going to abbreviate. Commutative property of addition means that A plus B is the same thing as B plus A. And order changes, and I put that with an asterisk there to kind of remind you this. So example, 2 plus 3 is the same as 3 plus 2. You end up at the same answer. Okay, next property is the commutative property of multiplication. So this property also works for multiplication. It just means that the order when you're multiplying, you will arrive at the same answer. It doesn't matter which way you multiply. So A times B equals B times A. Again, order matters because it's the commutative property of multiplication. Okay, 3 and 4, you've probably already heard of as well, are the associative property of addition and the associative property of multiplication. So now, when you're doing this, and if you notice I put it with an asterisk, order doesn't change. So what you want to look for to tell if it's associative versus commutative is that you see A, then you see B, then you see C. And you should see the same order on the other side of the equal sign, A, B, and C. However, the only thing that's changed is the group. So first we're adding A and B, and then on the other side we're adding B and C. So same thing with multiplication, it's A, B, C, and then it's A, B, C, and the only thing that changed was the grouping symbols, our parentheses. Okay. Property number 5 is the additive identity property. Identity properties are like mirrors. So you want to start with A, some number, and you want to do something to it and get A back, because when you look in a mirror, you see yourself. So what we do for addition is we add 0 and we'll still keep A. Okay, so you still see the A there. The multiplicative identity, you want to multiply the number by something but still keep the number, that's when we multiply by 1. And our last property is the multiplicative property of 0, basically telling you that anything times 0 is 0. So A times 0 is the same thing as 0 times A is the same thing as 0. Okay, so remember you should be pausing me if I'm going too fast. Some tricky examples. Write down some tricky examples. Don't worry about the fact that it says complete worksheet. These 2 examples are tricky because you see parentheses and most kids write immediately, oh, parentheses, associative property. They look at the operation, they write addition. However, one of them is associative and one of them is commutative. So if you look, here, remember to tell associative, you look for the order. We have 3, then we have 5, then we have 7, but then we have 7, 3, 5. So it's not, they're switching the order. What happens is they're switching this 7 and the grouping of 3 plus 5, and they're saying 7 in the front with 3 plus 5. So this one over here is the commutative property. Let me see if I can write with my finger because my pen is not working. Sorry. Commutative property of addition. Sorry for the handwriting, the pen is not working at the moment. For the next one, we have 3, 5, 7 and 3, 5, 7. So here, the order does not change. The only thing that changes is the grouping symbol.
Students can move to their next period again. All
Okay.
students should now be moving next period. Thank you.
Next, we have some mental math problems. In mental math, even though what that means is you're doing them in your head, but you still need to write it down because I don't know what you're thinking in your head. So mental math means you should be using your head, not using a calculator, not writing things down to solve it. You should be using your brain, but you still need to tell me what you were thinking. So you are going to need to write. You are going to need to write. Some examples. Number 1, to find this one mentally, you would want to change around the grouping so that it makes it easier to do. So for example, I would do these 2 first because I know that 20 times 5 is 100. And then what I would do is I know that 100 times 18, so I'll just bring down the times 18. And this is me showing my work, but I'm not using a calculator, and I'm not actually multiplying them out. I know what 18 times 100 is, because it's just 18 with 2 zeros after it, which is 1,800. Oop. Again, sorry, I don't have a pen. Okay. 1 second. Guys, can you go outside, please? Thank you. Okay, and for the last, it's called a counterexample. So what I'd like you to do is write down that definition. And you're going to tell me, and you're going to prove to me whether the statement is true or not true. And division of whole numbers is commutative. And what you would show me down here is, well, 10 divided by 2, and I'm just picking numbers. 10 divided by 2 is 5. But if I do it the other way around, if I do 2 divided by 10, you actually get a decimal. You get 0.2. So this would be my counterexample to show, no, it's not commutative. It does matter the order of which you do things. Okay, so that's called a counterexample. So copy those things down. We'll work more on this in class. Have a good one.